Good morning. Happy MLK Junior Day. For those of you in my Monday section who are not capable of coming to class today because we aren't having it, I put together this video, which is going to be a recitation section. And what we're going to do is work through the particular problems that you've requested and work through the problems that are also contained in the notes. These are kind of like professor's choice questions and requests from last semester. So those will be available as well. So first we're going to go into 1.1 and I'm going to start with the requests. I'm going to do that first because that's what you guys asked for right now. So I had a request for problems 12 through 15. So we're going to go ahead and take a look at those. So we're going to start with 12. This is a question regarding toolkit functions. Okay, you may need to peruse the slides for this one again if you need to. So let's start with this guy here. Okay, this is X. Let me zoom in a little bit so that you can kind of get a beat on what we're doing. First one of the semester, it's always a little choppy. So first one here, that is a square. The name for this function comes from the Greek word for square, which is quadrilis. That is a quadratic function. Okay, so that's going to be h. Since this next one, x cubed is raised to the third power, that is cubic. That's going to be b. Here for the third one, cubic root of x, that's undoing a cube. So that's going to be a cubic root. I know it seems like I'm kind of burning through this, but this is all just basic memorization of the toolkit functions. Okay, if you're doing anything crazy to remember these, you're probably doing too much. This next one here is a square root function. You just need to know them by name at this juncture for this question. This next guy, the straight brackets, that's your absolute value function. 1 over x, okay, this is a reciprocal function. All right, if I had like 2/3, its reciprocal is 3/2. You could think of that as 1 over 2/3 for whatever it's worth. Just x, you could think of this as y equals mx plus b. M is 1 and b is 0. That's going to be our linear function. And this is the reciprocal squared. Okay, so that's going to be g. All right, and I don't need my annotation anymore. Great job, me. All right, now this is a recognition question regarding graphs of toolkit functions. All right, so this is there again, there's really nothing fancy about this one. For the graph A, that is absolutely a square root function. Okay, so that's going to be this guy. For B, that is definitely a quadratic function, which is going to be this guy. C, that is going to be a cubic root. Where's my cubic root? This guy. All right, D, that is an absolute value. It's almost cheating. Absolute value, it makes a V, absolute value. Okay. That's definitely a linear graph. So that's for E, that's going to be linear. And again, this is just memorization, okay? I'm not doing anything crazy in my head, just looking at the graph with my eyeballs and remembering the name of it and the function it corresponds with. So F, that is definitely a cubic function. And again, that's just because I've memorized these toolkit functions. That's all there is to it. For G, that's a reciprocal, and H is a reciprocal squared. So the reciprocal is this guy, and the reciprocal squared is this guy. All right, we're doing it. Now, for this one, we're going to do a table. I'm not going to work through each and every one of these. I'm just going to go ahead and choose one and work through it and show you how it works. Let's do something like, let's go ahead and work through Let's do E. So this one I'm going to work through in particular because this is probably going to be one where folks got a little hung up. So the way I see this is I'm going to take -2, I'm going to do something to it, and I'm going to get -0.5, which -0.5, I can write that as -1/2. So this is testing your knowledge of fractions. -1, that's going to get mapped to -1. 0, you see here we've got something that's undefined. That's interesting. Okay. 1 is going to map to 1. That's fine. 2 is going to map to 1/2. And 3, if you think of 0.33 as a fraction, you could very well say it's 1/3. Now, something that might be helpful here, I can think of -1 as -1/1. I can think of 1 as 1/1. So if I look at the pattern, so I take 2, I do something to it. I don't know what that thing was. And now it becomes, I take -2, it becomes -1/2. That same thing is going to take -1, make it -1/1. 0 is going to be undefined, which undefined, we could think of this as 1/0. By observing this, we start to see the pattern here. It's almost like I took each thing and rewrote it as a reciprocal after I did something to it. So what that communicates to me is that this is going to be 1/x. Okay, this is going to be the reciprocal function. Right in the background, you can hear that my son probably broke in the room. Well, he definitely broke in the room, but you might not hear it. Who knows? So that's going to be an example of how we go about this. You may need to do a little bit of review on how absolute values work, how square roots, how cubes work. Let me know if you're running into any particular snags with that. All right, now let me hit number 15. All right, this one is really just the same thing as the last problem. You're just working backwards. So we're starting with the table, and instead of, well, we're not working backwards. We're just going to be choosing the name of the function instead of its graph. So again, what comes up here is you're going to need to know those toolkit functions. All right, so make sure that you kind of make note cards with them, spend some, or flashcards, like spend some time just memorizing the names of the function, the equations that correspond to them, and their graphs. All right, now let's go and take a look at problem 8. All right, so for this one, what I'm asking you to do is evaluate f of 3 and then solve for where f of x is equal to 3. So for f of 3, what I'm really saying is x equals 3. What does y equal? Another way you could think about this is I've got a coordinate pair. And the thing I know is the x value. I want to know what the y value is. So, okay, I look on the x-axis, I find 3, see where it goes on the function, boom, right here. And now I'm going to trace that to the y value, and I see the y value is 2. So the answer to this question is going to be 2. All right. And now I'm going to solve, so that's going to be this part here. I would write 2 in the place, and that's correct. Now I need to find where f of x equals 3. So let me get rid of all of this stuff here. I don't need to get rid of that, that's fine. So what I'm saying here is this is really just y equals 3. So x is what I don't know, but y is 3. You see, I'm asking kind of the reverse question here. Now I know the y value is 3. I need to find what the x value is. So in a similar ilk, I'm going to go to the y-axis, find 3. Okay, it's right here. And now I need to find where I touch the function, which is going to be right here. That's going to have an x value of -1. All right, so the answer here would be -1. All right, so now let's take a look at problem number 10. I'm only going to do like one of these, just, and you can peruse the notes and, work this on your own. Just for succinctness of time, let's keep the video as short as we can, right? So here's f of -1. Let's do that one first. And let's do that one in general. So what I'm saying is, everywhere I see an x, and I like to use kind of parentheses here, I'm going to put -1 in its place. Now make sure that you're utilizing your order of operations correctly. So right out of the gate, -1 squared, that's going to be 1. So I get 5 times 1 minus, 8 times -1, that's going to be -8. Parentheses liberally. Okay, I've never gotten into trouble because I used too many, but I've definitely gotten into trouble because I didn't use enough. Observe that subtracting a negative is the same thing as adding a positive, right? So I get 5 plus 8 plus 1. I just found a sexed up way to ask you, what's 5 plus 8 plus 1? It's going to be 14. Okay. Boop, boop, boop. All right, I'll leave the rest to you all. Let's take a look at number 11, and then I am sufficiently comfortable with what has been shown to you all for 1.1. So for this one, let's just go ahead and let's do B. Why not? So for this one, what I need to do is find what f of -1 is first, which is just like the last problem. I'm just going to plug -1 in there. It's a -3, -1 plus 2. Okay, so -1 squared, that's 1. So I get -3 times 1. Or -1 squared is 1. I hope I said that right. And then I get -6 plus 2. All right, so that's -7 if you crunch out the numbers for this, okay? Because that's -3 minus 6, that's -9 plus 2, -7. Now we're not done. I need to find what f of 1 is. So -3 times 1 squared plus 6 times 1 plus 2. So now I get 1 squared is 1, so I get -3 times 1 plus 6 plus 2. So that's -3 plus 6 is -3. Or I'm sorry, -3 plus 6 is 3, plus 2 is 5. All right, now we're not done. We need to do the subtraction here. So what we get is -7 minus 5. That's going to be -12. Let me write that like I have penmanship. There we go. -12. Okay, so that's really I'm asking you to do, 2 evaluations and then a subtraction. Okay. I almost asked, are there any questions on this, but I'm the only one in this room as of now. But I don't think my son has any questions just yet. So let's go ahead and go into 1.2. Yep, I'm cool with that. So now I'm going to work into the domain and range notes. The notes already have problem 13 done on there, but that was a request, so I'm going to start there. Yes. So this one here, I am if you are doing this correctly, but there's like a little goofy goober in there somewhere, send me a message on Lumen and I will help you button it up. So what we're going to do is we're graphing a piecewise function here. So the first kind of component that I'm going to pay mind to is the constant function 1. So what that would look like is a horizontal line at 1. Now, I don't want every part of this. I only want when x is less than or equal to -1. So here's -1. And so what I want is only the left part of this. So I would get rid of this part. And I'm going to include it, so I'm going to have a closed circle at the end of that here. All right, so let's go ahead and choose the correct things to model that. So what I'm going to choose is this guy. I'm going to put my first point here. And then I'm going to extend it indefinitely. It doesn't matter where I put the other point, right? It's going to extend indefinitely there. And I'm going to put a closed circle, boom, right here. Now, for some folks, they use the line segment tool. If that was the only thing you did wrong, I promise I'm going to go ahead and give you credit for that. Okay, just send me a message through Lumen. Now, the second thing we're going to talk about is this function here, x. Okay, remember x is a perfectly diagonal line, but I'm only going to go from -1, not inclusive, so that's going to be an open circle, up to x equals 1, but it's less than or equal to 1, so then it's going to be closed. All right. And so what I'm going to be looking at here is a section that looks like this. Boom, -1 up to 1, because it's an identity function. Boop, something roughly like that. All right, so let's choose the appropriate graph for doing this. Turn off my annotations. Boom. So it's going to go from -1 to 1. Actually, I'm realizing that I would do well to use the line segment tool. I'm being a goon. We'll do that. And then an open circle on the left-hand side, and a closed circle on the right-hand side. That's the sound it makes. Okay, great. We're doing it. Now we're going to do our last function, which I will do that in purple. We've got the constant function 3, which is going to be a horizontal line at y equals 3. But I only want when x is greater than 1. So here's where x is 1. I'm only wanting to, at this point here, it's going to be an open circle. And I don't want any of this nonsense. I don't want anything to the left of 1. All right, so let's go ahead and make that happen. So we'll start with an open circle here, 3. And what I'm going to do is use the line tool, the ray tool, and extend it indefinitely. Okay. Again, the thing that got folks into trouble on this was the line segment tool. But if that's the only thing you got wrong, hey, we're good. You did awesome. Okay. So that's the 1 out of 1 on that one. So that's where there's a little bit of confusion on that. Again, if the reason you're getting it wrong is like something goofy like line segment instead of ray, that's totally fine. If it's like open circle or closed circles in the wrong places, that's a big deal. And that's really important to button up. I won't be awarding full credit for that, but you will get a good bit of it. Okay, so that's going to be our final result. That's the graph that we're trying to replicate, and we have the tools on Lumen, which aren't glamorous, but they're fine. They're not the worst. I've definitely seen worse tools out there. All right, so let's take a look at question 3. What you're going to do here is find the domain and state the answer in interval notation. Now, for domain, there's 2 things that we're always going to check. The first of which is division by 0. You know, is there ever going to be something over 0? It doesn't matter what that something is. I've heard folks say, well, 0 over 0 is 1. That's not true. If you want to know why, come to my office hours. Since there's no division by anything containing x in this function here, we don't need to worry about this. This is not even remotely, of concern. Now, in the case of an even indexed radical with a negative under there, that actually is possible. If you take a look at that 2 minus 4x under that square root has an even index. I got to worry about what's going on with that 2 minus 4x. So what I want to know is, what I'm really asking is, when is 2 minus 4x negative? When is that negative? So what I'm going to do to find that out is I'm going to set up an inequality. And say, all right, a number is negative when it's less than 0. And now I'm going to go ahead and solve this inequality. And there's a couple different ways you can do it. You could subtract 2 from both sides. You get -2. And then you can divide both sides by -4. And then just mind that when you multiply or divide both sides of an inequality by a negative, you reverse the sign. And we say, okay, x is greater than 1/2. That's where a bad thing happens. When x is greater than 1/2, I end up with a negative under that radical with an even index. So what happens is, and by the way, if you wanted to, you could have just moved the 4x over to the other side of the equation, and then you're not dividing by a negative, which is pretty cool. That's totally fine. So now, what I'm saying is, everything that is bigger than 1/2, okay, do this in purple. This is all bad stuff. We can't include any of this. So since this is all the bad stuff, the purple stuff is all the bad stuff, what we're left with, if we remove all the bad stuff, is we're left with the good stuff, which this now is our domain. So if I'm going to write this as an interval, I'm going from -∞ to 1/2. I'm including 1/2, so that's a bracket. Let me really emphasize the bracket there. And so that's my domain. I've had students message my instructor through questions like this and been like, oh, I used a parenthesis instead of a bracket on 1/2. Like, obviously, you can just give me credit for this. No, it's a big deal to make sure that we include a point or not. Okay, if we don't include 1/2, then what we're saying is that the square root of 0 is illegal, which isn't true. It's boring, but it's definitely legal. Okay, so make sure that you are being really thoughtful about the notation you're using. All right. Now let's talk about number 4. All right, for this one, we've got both things we need to worry about. So in the way of division by 0, what we need to do is see when is x minus 2 equal to 0. Well, okay, fine. So we add 2 to both sides, x equals 2. That's a bad thing. So let's start with our, oh gosh, that looks really bad. That's okay though. So we'll just put 0 as a frame of reference. Here's 2. Can't have 2. There's going to be an open circle at 2, no matter what happens here. All right, now I need to check my second thing, which I'll do in purple. The index of this radical in the numerator is technically 2, right? I didn't write it, but it's 2. So I might have a negative under a radical with an even index. So what I need to do is know, when is x plus 4 negative? When is that negative? When is it less than 0? Well, I'll subtract 4 from both sides. When x is less than -4, that's where the other bad thing happens. All right, so open circle here. This is all the bad stuff. And when in doubt, choose a value and check it out. So if I chose like -7, right? What's -7? -7 plus 4. Well, that's -3. Since all of this was under a square root of -3, that's not okay. In the real numbers, I mean, it's fine for what it is. All right, so now what I'm left with is everybody bigger than -4 is legal. But don't forget that 2, we already said, was supposed to be an open circle. So what I need to do is, in my appropriate domain, is come up to 2, give that an open circle, and then skip over it. Now, I don't need to trouble myself with the bad stuff anymore, so let's just go ahead and write our domain here, and don't worry about the multiple choice portion of it. So for this interval, I'm starting at -4, and I'm including it. I'm going all the way up to 2. But I'm not going to put a bracket here. I'm going to put a parenthesis because if you notice, I can't be 2, right? Because then that circle would be closed. And then I'm going to start at 2, and I'm going to go up to infinity. I'm going to use parenthesis around that because I can't be infinity. And I'm going to put these two spaces together. That's going to require a union. That's going to be the first part of the problem. Now, I understand that with process of elimination or things of that effect, you might be able to select this right out of the gate. But it's important that you know how to write these types of intervals. Okay. Now, I understand that this guy, x cannot equal 2, seems really tempting. The problem there is you're also including in, we'll call this choice C, you're also including stuff over here because -7 isn't 2, certainly. So you would say, oh, well, I mean, -7 isn't 2, so it works. But as we saw up here, -7 doesn't work. That's actually hugely problematic. Okay, let's do 5. So I've got 5, 6, 8, 10, and 11. All right, so for question 5. And these are all on the notes, okay? The numbers are going to be different, but these are all on the notes. Again, I look for divisions by 0, radicals under, no, I'm sorry, negatives under radical with even index. Clearly, just by looking at this, okay, I don't need to worry about radicals under, or negative under radicals with even index because there are no radicals with even index. So I only need to know when is this thing equal to 0. And so there's a couple different ways you can do this. You could use factoring. You could use quadratic formula. I'll go ahead and use factoring. I think factoring is really, really quick. It already equals 0, so that's pretty great. So if I think of this as 1x squared, the way that I like to factor is I'm going to multiply, think of this as ax squared plus bx plus c, okay, equals 0. So my a value is 1, my b value is 7, and my c value is -44. Okay. So I'm going to multiply a and c first, and I get -44. 1 times -44 is -44. And now what I'm going to do is I'm going to look for two things that multiply to -44 and add up to the b value, 7. I'm going to call those my magic numbers. Okay. So I think about this. What about 11 and -4? Okay. You're going to do a little bit of experimentation and you'll probably, stumble upon these quickly as well. If not, it's just a question of practice. And so now I get x squared. I'm going to break up my middle term as 2 x's, which is kind of weird, I understand. So we've got 11x, and there's the 4x. And now what's really cool about this is what I get to do is since I now have 4 terms, I can use greatest common factor and factor by grouping. So in the first term, I'm going to take an x out, and I get x plus 11. That's pretty great, I guess. I don't know. We'll see. And then in the second term, I'm going to take out a -4. My son has some very strong feelings this morning, and it's important that he shares them. This is a house where we are very passionate about each other's feelings as well. And so cheers to him. So now we end up with x minus 4 as one factor and x plus 11 as another. Now for the zero product property, if I've got two numbers that multiply to give me 0, at least one of them has to be 0. So I'll leave the small equation here to you, but I've got x minus 4 equals 0. So x equals 4. That's going to be where one of the bad things are. And then x plus 11 equals 0. Well, that's going to be -11. That's where the other bad thing is. So where are both of those bad things represented? This guy here. Okay. I can't be -11 and I can't be 4. I should probably clear everything out. you'll notice that I'm kind of like very intentional in the way I move back and forth between tools and features. You know, it's Canvas, or not Canvas, I'm sorry. It's the beginning of the semester. We're getting used to it. This is Zoom, so this is who we are now. All right, so question 6 for domain, because I'm hilarious and I have really great jokes and everyone really appreciates my pop culture references. For domain, I told you guys that we need to reference Beyonce. So we start to the left, How far to the left does this thing go? Goes this far. Now, what is that point? X is -1. How far to the right do we go? We go here, X equals 5. And it looks like we're going to include everyone in the middle. So that's great. If you need to, draw a little number line so you have this as a frame of reference. So I know that I'm going to include everyone in here. And then the endpoints, right? Let's take a look at 1 and 5. Those are going to be open circles. All right, so that's going to be my domain. Now, how do I write this as an interval? Well, -1 is going to be in parentheses because I'm not going to include that as an endpoint. And 5 is going to be in parentheses. I'm not going to include that as an endpoint. Okay. So that's how we find the domain of a graph. Don't overthink this. It's really just looking with your eyeballs and writing out an interval. Okay. I'm not telling you it doesn't take practice, right? But it's one of those things where it's incredibly visual. So if you're doing a bunch of algebra and carrying the 5, like you're missing something here. Man, my son is having a tough morning. I don't know if y'all can hear it, but he is having a tough morning. All right, so for this one, we're doing domain and range. So again, for domain, we are going to reference Beyonce. So we go all the way to the left. How far to the left does this thing go? Looks like -3. Okay. And it looks like we go up to 2 on the x-axis. That's great. Everyone in the middle is included. That's great. At -3, observe that's a closed circle. So we are going to include that as its leftmost endpoint. And at 2, that's going to be an open circle. Everyone in the middle is included. So if I want to write my domain out, pause the video and try it yourself. You should have -3 up to 2, parenthesis. That's going to be my domain. Now for range, we're going to reference Drake for range. Start it from the bottom. So this point is as low as we go. On the y-axis, that's -5. Okay, cool. So we've got -5. And I'm going all the way up to how high does it go? Most folks are going to let their eyeballs fall on this point. No, 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 no. We want to go as high as possible. That's going to be up here. And now if I look at the graph, I see that that point at the top is technically included. So at 4, I'm going to have a closed circle. And at -5, I'm going to have a closed circle. Now, am I including everyone in the middle? Well, okay, everything here looks fine. When we get to this open circle, some folks are going to say, oh, we're not including 0. But look on the left-hand side. See here? This is closed. So 0 is included in the range. So don't fall for the open circle trap. The slide segment's going to be all the way filled in. Pause the video and write this out as an interval. All right, we're going to have -5 inclusive, 4 inclusive, and that is my range. Again, make sure you're using proper notation for these intervals. All right, now let's do problem 10. So for this one, this is a piecewise function. I'm asking you to evaluate it at particular values. So for f of -1, I've got these 2 equations I'm going to choose from. We'll call this one A, and we'll call this one B. the equation I'm going to be plugging -1 into is actually going to be a in this case. So it would be 2 times -1 plus 8, which is -2 plus 8, and that equals 6. Why do I plug that into a? Well, since x equals -1 in this case, -1 is going to be in the space less than 0. So that's where it goes. So the equation corresponding to that particular domain is 2x plus 8. Okay. All right. So the answer for this guy is 6. Now, for 0, what we're going to do is plug 0 into its appropriate equation. Well, that's actually contained in this space because 0 is greater than or equal to 0. So now I'm going to plug that in here. 2 times 0 plus 16 is 16. And then for 2, I'm saying x equals 2. That's also in this universe. So the thing that most students are going to get wrong on this is they're just plugging the x values into the wrong equation. They'll either plug it into an equation willy-nilly, or they'll end up just choosing the x value as the output, okay, which is not the case. And now the last one we're going to do in this video is number 11. And what you're doing here is you're labeling domains. Well, you're labeling the domain for a particular piecewise function. And in order to do that, you're labeling particular domains. So let's start with this line segment. This is definitely y equals 5. And then we'll jump down and do this line segment. This is definitely y equals 4. And then we'll do this line segment. This is definitely y equals 3. So now the question becomes, what are the corresponding domains for this? So let's take a look at 5. That's the red line here. That's running from -5 to 3. And in particular, if you need to draw this out separately, there is nothing wrong with that. You see how there's 2 closed circles on the line segment? So I'm going to be including that. All right. So my interval here is going to be -5 to -3. All right, now let's take a look at 4. So here's 4 and here's 4. Let's write that out as an interval. Again, you don't have to scale these or anything like that. At -3, and we're going up to 1. Okay, that's going to be this point. At -3, I've got an open circle. 1 is closed. And if you look, everywhere in the middle is included. All right, so that's great. So now take a second and write that as an interval. Should get -3 to 1. Right, and now let's address y equals 3. We're going to follow the same type of procedure here. We see that our endpoints are 1 and 4. Everything in the middle here is included. And at 1, it's going to be an open circle. 4 is going to be closed. Everyone in the middle. Okay. So my domain here is going to be 1 to 4. And that is everything and then some that's going to be covered in the week 2 recitation section. Have a great day. Enjoy your week.